Hey guys, we'll go ahead and get started. Sorry, my hair is looking like I'm from the movie Grease. I just got out of the shower, but throughout the video, it'll probably poof back up and dry out. So my name is Matt. I am currently a sophomore here at BYU, and I decided that it would be good to maybe go over some of the heat and energy formulas and kind of what they are, so we're better prepared for our final. I meant to get this video out yesterday before exam 3, but got caught up for studying with it by myself. So hopefully if you're looking at this, it'll help you with the final that's coming up next week. But I'm going to go ahead and start this. Hopefully everyone can see this. Okay, so like I said, I'm going to be going over heat, energy, work. I got a couple practice problems. This should take us up to about the hour mark if I prepare it accordingly and how things go. So, but my name is Matt. I'm from here in Provo, grew up here. But yeah, let's just dive into this. Okay, so obviously before we get started, we want to understand what we're dealing with. So heat, energy, and work. The first thing we're going to learn is that the first law of thermodynamics is energy cannot be created nor destroyed, only transferred. So if we're looking at the two equations that were given, the change in energy of the universe is equal to 0. So that means, energy can only be transferred to and from. And with the practice equations that we're going to do, it'll make more sense. But the other one is the energy of the system is equal to Q plus W. Q plus W is Q is heat and W is work. So the energy of the system has to be equal to Q plus W. So obviously Q is going to be our heat. So what does that mean? Heat is anything that is absorbing heat, or it can be releasing heat. If it's going to be absorbing heat, you're going to see a positive Q, meaning that it's also endothermic. And then anything that is releasing heat is going to be a negative Q, or exothermic. Something that I forgot to put on here is that when going from a solid to a gas, it's going to be sublimation. And then from going to a gas to a solid, it's going to be deposition. So those are things that I kind of always get confused on. So if you're one of those people that gets confused on that too, that might be good to jot down in your notes just so you remember, okay, if I'm going from a solid to a gas, that's going to be sublimation. Or if I'm going from a gas to a solid, that means it's going to be deposition. So it's going to be losing heat. And then the other one we have is work. So work is our W. And our W is going to be a positive W if the surroundings do work on the system. So if something else around us is doing work on us, then it's going to be positive because we're receiving, we're absorbing. In the sense, if we're looking back at the heat thing, something is doing something on us, so we're receiving. And then when we're expending our energy, the system does work on the surroundings. So that's whatever it is doing work on something else, so you're releasing that work. So it's going to be a negative W. Hopefully no one has any questions on that. Tried to make it pretty simple. I'm a very simple learner, so I hate things that are really complex. So I try to dumb it down as much as I can. That way I can explain it to other people, and hopefully they can understand it as well as I do. Okay, so with heat, you're going to see a lot of different equations come up. I'm not sure which ones are going to come up on the final exam. Yesterday's exam, the bomb calorimeter number 4 did not show up. Everything else did. As far as the final goes, they'll probably will throw in a bomb calorimeter one. So it would be good to know this equation, know how to do practice problems with it. That way when it comes to the test, there's probably only going to be like one of them. You're just comfortable with knowing how to do it. I didn't throw a practice equation in for one of these, but I did do some temperature changes ones and whatnot. So we'll be able to look over those. But with the 4 equations that you're going to see, I think they give these to you also on the final exam as well, on the chemistry equation sheet that they give out. So you should have all these down. I don't think there's any reason to memorize them unless you want to. I find it beneficial to memorize them. That way I'm not like flipping back and forth on pages, wasting time. But so anyways, so when you see a temperature change, you're mostly going to be seeing Q equals MC delta T. And so our Q is our heat, M is our mass, C is the energy that's being used, and then change in temp. The data is change in temperature. So we're looking for those three things. And as we do practice problems, you'll see how I kind of like to write it out when I'm doing them. That way I don't get the numbers mixed up. So definitely going to see some of these questions on the final exam. Then we have phase changes. Phase changes and reactions are the same equation. So whenever something is changing from like a solid to a liquid, or maybe like a liquid to a gas, you're going to see this equation being used because a reaction is happening. And it's also going through a phase change. So let's say you're making a cake, you put it in the oven, reaction is going to take place, right? You had this, you had the dough all laid out, whatever, if you're making cookies, and then you put them in the oven, boom, the reaction is going to take place, and you're going to get your cookies. So in that type of scenario, you would use these two. So if a phase change or if a reaction is happening, you're going to use Q equals N, which stands for moles. Everyone should be familiar with that. And then the change in enthalpy. So that's our delta H. So that's what you're looking for when you're coming across the questions. You're looking for, okay, is it changing in energy? Is it changing, is it having a phase change? Is it going from a liquid to a gas or a solid to a liquid? So those are the kind of things that you're looking for. And then the Baum calorimeter, like I said, I didn't put a question in here, but what it would look like is they're going to take a substance. So say you have a beaker, they're going to take this Baum calorimeter and they're going to put it inside that beaker of water or fluid or whatever they have in there. And they're going to have a reaction happen inside of that Baum calorimeter. And so what our job is to do is to calculate the change in temperature and the heat that's given off by that reaction inside. So you could very well likely see it coupled with a C cal delta T plus an N delta H, because you'd have a reaction plus the temperature change and everything happening inside the Baum calorimeter. So if you're not too sure on that, hopefully you can go on to like YouTube or go watch Khan Academy. I find myself there a lot watching their videos on how to do stuff with chemistry, or you could ask Dr. Mortensen. I'm sure he'd be happy to explain it better. But those are the four equations that you're going to be seeing throughout this review session. And it is very, very, very likely that all of these will be tested on the final exam. Obviously, I'm not a TA or anything, but from what my personal tutor has said and what he's seen in the past, that's what he suggested that I study and know how to do. And so, yeah, we'll move on. So we're going to get into some practice problems. So I thought it'd be good to start out simple and then make them a little bit harder as we go on. So kind of progressing, so you build some confidence. That way it's not like you get to the first question like, crap, I don't know how to do this. This one's very simple, just looking for whether this is endothermic or exothermic. So go ahead, hit pause, do these. I have all of these. So you'll just do all of them. So dew forming on grass overnight, is that endothermic or exothermic? Deposition, is that endothermic or exothermic? And for all those, you do the same thing. So go ahead, hit pause, and do those really quick. Okay, you should have had some time to do that if you hit pause. We're going to keep moving on. So dew forming on grass overnight, that's going to be an exothermic reaction. Why? Because you're moving from a gas to a liquid. So the dew is taking the moisture from the air and putting it on the grass. So you're going from a gas to a liquid. That's why it's an exothermic reaction. It is releasing that heat. Deposition, same thing. This is really good to know. I mentioned it previously. Sublimation is going to be endothermic. Deposition is going to be exothermic. So you're going to be releasing that energy. Ice cube melting, you're going from a solid to a liquid. So that is, you know, also endothermic, right? You're releasing energy, or sorry, you're not releasing energy with an ice cube. You are absorbing energy because you have a solid here, and then it's going to a liquid. And then water vaporizing, same thing. You're going from a liquid to a gas. So vice versa of the dew forming on the grass, you're going to have the opposite effect where the water is evaporating into the system. So hopefully those are pretty straightforward. You probably will see one or two of these on the exam. I think there was one yesterday on exam 3, if I remember right. Very, very straightforward. Nothing to be worried about. But yeah, we're going to make these slightly harder as we go on now. Okay. Which of the following best describes heat? So if you remember what heat is energy that is absorbed or released. So the best definition for it, you just kind of look at it, see what one you feel like fits best. Go ahead and pause this one, circle the right answer that you think is right, or just take a mental note of what you think best describes heat. Okay, hopefully you had enough time to get that down. The answer will be A. And so the energy transfer between objects because of difference in their temperature. So that makes sense because heat can only be transferred, right? If we're going back to the equation, energy in the universe can only be transferred between objects, right? So heat being transferred, the energy transferred between objects because the difference in their temperature. So temperature is the key word there that kind of lets you know, okay, we're dealing with heat. So hopefully you got that right. Pretty simple question. Yes, moving on. Okay. Which of the following best describes work? Okay, so we just learned that heat is the transfer of temperature between two objects. So what do you think work is going to be? Work should be probably the same thing, just with the regards to work. So I'll give you a second to read through those, circle the one you think is right. Okay, hopefully you got that right. Not too different from the heat definition. I mean, they're going to keep them pretty similar. So the energy required to move an object through a given distance. So that's work being done. Energy is being expended. That way you can get object from point A over to point B. So that is describing work for us. So hopefully you got that right. I'm going to move on to the next one. Okay, internal energy. So now we're going to get into a little bit more complicated questions. These next ones that we're coming into are going to be more math-based. As we saw in the exam yesterday, lots of math problems. So hopefully these other math problems that I give you later down the line will be able to help you better prepare for the exam coming up for the final. So internal energy, this one's going to be based on internal energy. So whenever we're dealing with internal energy, it's our delta E equals Q plus W. So I reworded this to make it slightly easier to understand because most of the time these questions are going to say what combinations of conditions will result in decrease in internal energy on the system. And so they don't tell you that there's also going to be a decrease in work. They just tell you, okay, there's going to be a decrease in internal energy. So you know that Q is also, internal energy. So you're thinking, okay, what's decreasing? Is it the heat, or is it the work, or is it both? Is it one of them, both of them? So on the test yesterday, from what I saw, it looked like they had an increasing one that said what combinations of conditions will result in increase in the internal energy of the system. And for me, that was kind of confusing at first when I was learning it, because I was like, well, I know it's going to be an increase in heat, but I'm not sure about work because it just says of the system. And so I tried to dub it down a little bit and make it easier. So go ahead, pause this one. You're looking for what happens to heat and what happens to work. Yeah, so you should be able to get this one pretty easy. Okay, so if you do that correctly, you should get B, the system loses heat and does work on the surroundings. So if we back it up to the equation plus what we know about Q and W, so the equation is delta E equals Q plus W. So that means whatever's happened to Q, if it's positive, that means W is going to be positive, right? Vice versa, Q is negative, W is going to be negative. And that's why on those questions, they're not asking you what happens to work, because they expect you to know, okay, if it's a decrease in heat, obviously there's going to be a decrease in work as well. So that was something really hard for me to first grasp my hands on. So hopefully that sums it up for you a little bit better. But for this one, so we're looking at the decrease in the internal energy. So we know that the Q is going to be negative, so it's losing heat. So right away, it's like, okay, we can narrow it down to A and B. And then decrease of work. So that means, okay, the system is doing work. It's expending its energy. So we know, okay, that's going to be a negative W. So we know that the system loses heat and does work on the surroundings. So we have a negative Q and a negative W. So those will always be coupled together. So on the test, if you see increase instead, just know that increase in heat is also increase in W in work, and decrease in Q is decrease in W. So hopefully that was pretty easy. These were all more of the conceptual ones. Now we're going to be working our way into more of the math problem ones, which are a lot harder, take a little bit more thought process, because there's a lot of convergent factors you have to do. Okay, moving on. So here we go. Also dealing with heat. So how much heat is required to raise the temperature of 3.79 grams of aluminum from 40 degrees to 100 degrees Celsius? The specific heat of aluminum is 0.890 joules per gram times Celsius. So if you know how to do this, great. Go ahead, hit pause, see if you get the answer right. But for those of you who don't know how to do it, so what we're looking for here is what's happening in the reaction, right? Or what's happening in the equation. So we know that, I'm gonna write this down, sorry. Okay, we know that our heat is required to raise the temperature of 3.79 and grams of aluminum from 40 degrees to 100 degrees Celsius. So we know there's a temperature change, right? So we're having a raise in temperature, and they give us the specific heat of aluminum and say it's 0.890 joules per grams, right? So we have all the tools that we need to get to our answer. All we need to do is set up the equation. So if you remember, our equation for this is going to be Q equals the mass times our C, which is the joules they give us, times the change in temperature. So that's our equation we're going to be using. Q equals M, I call it MCAT. That's what my tutor tells me to call it. So that's what I call it. So Q equals MCAT. So if we're to write this out, super simple. We're looking for a mass. So M equals 3.79. Then it gives us our joules. So C equals 0.890 joules per grams. And it's really important to keep these labels well, because throughout the test or other equations, they will try to change the grams or kilograms. You know, they're going to change the units on you. So it's important to keep them constant so you know what you have. And then we're looking at our temperature change. So super simple temperature change. I actually changed this. It had decimals before. I just want to make it slightly simpler. So we're going from 40 degrees to 100 degrees. So that's an increase in temperature. So we're going to have a positive change in temperature of 60 degrees. So our change in temperature is 60 degrees. Okay, we have everything we need. So this is actually, it's a simple one. I try to keep it simple from the beginning. So Q equals MCAT, M equals 3.79. Our C equals the joules they give us, and our change in temperature is 60 degrees. So when we multiply all this out, I actually have it up on the slide, so I'll just go to the next one. But when we multiply all that out, we're going to get our heat. So this is how I like to set it up. So Q, that's what I'm looking for. I don't know how to find it, or I do know how to find it. All I need to do is plug in all those units. So I put in the mass, 3.79 grams. Then I know that our C is the joules that they give us. So put in our C. And then I know the temperature change was a positive 60. So something to be careful on is it could have flipped that and said, what is the temperature change when aluminum goes from 100 degrees to 40 degrees. So then you'd have to think, okay, it's decreasing in temperature, so that's going to give me a negative 60, right? So just something to be aware of. Those words can kind of get hard. So look, the keywords are increase, or if you're looking at the thing and you can tell it's increasing in heat or decreasing, those will be important for your temperature changes as well for those numbers, because they're very well likely are going to put the answer on the test of the opposite that you get. So if it says increasing and you put decreasing, that number is going to be on there to throw you off. So just be careful of that, and you should be fine. So if you did our math right, we should get Q equals 202.386 joules. So hopefully you did that right. And if you have any questions, just pause the video. I have everything written up here, and you should be able to figure it out from there. Okay, we're going to go into another heat equation. So same thing, this one's going to be slightly harder. I tried to start with an easy one, build up, make it harder as we go on. That way we're not losing confidence. We're building on our confidence, right? So we started with some easy conceptual ones. They got harder as we went on. Now we're going into the heat equations that are going to be dealing with 2 of our temperature changes and whatnot. So let's go ahead and read this one. A 0.04 kilogram piece of gold at 76.2 degrees Celsius is dropped into 10 grams of water at 20 degrees Celsius. After a short time, both the gold and the water reach a stable temperature of 26.2 degrees Celsius. Use this information to calculate the specific heat of gold. And the C, they're giving us our C again. So C water equals 4.184 joules per grams. Now this is a very constant number. You're going to see this a lot for water's C. And so, the C is the heat capacity. If you weren't familiar with what C meant, C is our heat capacity. So the heat capacity of water is a constant. So if you want to memorize this number, because most of the time they should give it to you, I think. But I think it's really good to memorize these numbers because you see them so much. That's just a lot easier to like, oh yeah, I know that the heat capacity of water is 4.184, So you don't have to really, go searching for that number. But on the test and exam, they should give that to you. If they don't, I would be surprised. But sometimes they do expect you to know stuff. So really good number to memorize if you haven't already. So the heat capacity of water is 4.184. Okay, we're going to do this equation. So I like to set it up the same way as last time. So I'm looking for what's happening. So looking for temperature changes, looking for if they give me the mass, I'm looking for if they give me the heat capacity of a certain object. So we'll just start with gold. So on my paper or on my whiteboard, whatever you're using, I like to write gold on the left side because I see that there's going to be 2 things that we're going to be dealing with. So we have gold and we have water. So I have gold on the left side, and I kind of draw a line down the middle, and we put water up on the right. So kind of like that. I actually think my number I think that's all backwards for you. But water and gold, right? So with our gold, I already know that this equation is going to be a Q equals MCAT plus MCAT. So all I have to do is figure out what they give me and what I need to find. So if I'm setting this up, I look at it, I say, okay, M of gold, the mass of gold, is 0.04 kilograms. And make sure to write out these units because it will play a factor in the equations further down the line. Okay, so our mass is 0.04, very simple. So our C, we're looking to see if they give me the heat change, the heat capacity of gold. Looks like they don't, but they do for water, so you can make that note. So on the water side, I'd put the heat capacity and put 4.184. Once again, that is a constant number. Very good to memorize if you haven't already. Going back to the gold side, we're looking for our change in temperature now. And this is where stuff can get kind of confusing because sometimes they will give you the change in temperature, say it changed this much, and other times you have to calculate it. So I'll try to help you guys out with this one. So it looks like, we read again, a piece of gold at 76.2 degrees, that's its starting temperature, right, is dropped into 10 grams of water. They give us the mass of water, so we might as well just write it down right now. 10 grams of water is our mass at 20 degrees Celsius. So the water is at 20 degrees Celsius, and the gold is at 72.6 degrees Celsius. Okay, both the gold and the water reach a stable temperature of 26.2. Boom, there's our temperature change. We're going from 76 degrees to 26.2 degrees. So our gold dropped in temperature, right? So we're going to see a negative 50 degree change for gold. So gold went from 72.6 degrees to 26.2 degrees. You do the math, very simple math, just a negative 50. So we have negative 50 degrees is our temperature change. We don't know our heat capacity of C, that's what we're looking for, and they give us the mass for the grams. Okay, moving on to the water side. If you're filling it out as we go, you should have mass equals 10 grams for the water, and then they give us the C, the heat change, which is 4.184 joules per grams. And then they also give us our temperature change of water. So if we're looking at it, so water started at 20 degrees, right? But then it finished at 26.2 degrees. And that makes sense because we have a very hot object, gold, being put into water. So obviously our temperature change, that hot gold is going to raise the temperature of our water, right? I like to visualize it too. So, I mean, we're dropping gold in, really, really hot gold, boom, drops into the water. The gold is decreasing in temperature because it's absorbing the heat of the water, and the water, vice versa, is absorbing the heat of the gold. So that's going to raise, and the other one's going to drop. So it should be just a simple 6.2 degrees in change of temperature. And this is positive, our other one was negative. So just remember that those are very important as well. So water started at 20 degrees, went up to 26. Gold started at 76.2 degrees, went down to 26.2. So that's a decrease. Okay, now we have all of our numbers. On the next slide, I've got it all written out for you. So if you do the math right, and you set it up, I like to set it up this way. I don't know if you can see all that, but it makes it really easy for me to know what I need to find and how I need to find it, because that's a lot of information to take in. If you're just looking at it, there's a lot of numbers. You're like, oh, okay, what do I do? But if you break it up and you say, okay, I know I have gold, I know I have water. Okay, awesome. That means I'm going to have two separate equations being added together. So what equation am I looking for? Oh, obviously it's going to be Q equals MCAT plus MCAT. Then I look for the units they give me. Okay, they give me the mass, they give me the temperature on the gold side. Okay, on the water, they give me everything. Great, that's gonna be super easy. So if you do the math right, this is what it should look like. So there's our equation on the left, Q equals MCAT plus MCAT, that's what we're looking for. I drew it on my board here. I do think it's backwards for you guys, the writing. So you can't see it, but I've got it there on the slide. So you should be able to see that that's what we're looking for. And I did mess up here. I just noticed this. Okay, no, they gave us the the heat capacity of water. So that 4.185 should be on the water side. Obviously, we're just adding it together, so it didn't change. No, yes. Gosh, I did that all backwards. No, just that one part. Okay, yeah, so that 4.185 should be on the opposite side, should be on the water side. Actually, just go ahead and change that really quick. That way. Okay. And then to perfect. Okay. Awesome. Okay, that should be right now. And I didn't put the units on for the joules. Like I said, I'm going to do that really quick. Joules per grams. Okay, cool. I caught that. Okay, awesome. So if you did the math right, you should get 0.13 joules per grams times our Celsius. So pretty straightforward. Just recognizing that we're going to be using two equations. So we have Q equals MCAT plus MCAT. As long as you recognize that from the bat, everything else should be given to you, and you just have to do the math. So moving on. Oh, that is my last question. I thought I had one more. Okay, so that's the last one. I didn't try to make this very hard. I just tried to make it simple enough to where you could be confident in getting these answers on the test, because you're going to see a lot of equations like this from yesterday. I think I did like 2 or 3 of them that were like this. Some of them had where you had to find the n, back to this one right here. Some of them had the n delta H plus MCAT, so I had to look for the enthalpy, and then find the moles as well, and then add that with the other things that they gave me. Everyone should have had the same experience on the test that I did, same questions. But yeah, just quick recap. I'll just breeze through really quick. We went over the first law of thermodynamics. So I guarantee there'll be a conceptual question on this. There was one yesterday. That's just knowing that energy cannot be created nor destroyed, only transferred. So the equation with that is delta E of the universe is equal to 0. And then with that, we're going to have our delta E of the system is equal to Q plus W, right? So our heat is our Q, our work is our W. Heat absorbs Q. So heat can be absorbing, so that's a positive Q, or it can be released, that's a negative Q. We saw those in the questions that we did. Then the other things to just remember are that if it's going from a solid to a gas, or solid to a liquid to a gas, that is absorbing energy. So that's going to be our positive Q, meaning that it's endothermic, right? And then if we're going from a gas up to a solid, gas, liquid, solid, that's releasing heat. It's releasing energy. So that's going to be our negative Q and exothermic. Okay, back with work. Work is the surroundings that we do on the system. So that's our positive W. So work is being done on the system. And then our negative W is system does work on the surroundings. So work is being exerted, losing energy. Okay, then the 4 equations. We did a couple practice ones of these. So obviously we're going to have our temperature change, right? We saw one with that where we just have to plug in all the numbers, and then it gives us our energy, our thermal energy. So Q equals MCAT. Super easy there. I didn't do a phase change one in our thing, or reaction, or a bomb calorimeter, but know how to do those because they will show up on the test. I almost guarantee it. I saw some yesterday, and so it's good to be knowledgeable about how to do those And then, yeah, I mean, we already went through all these. So hopefully that helps you out for the final, or maybe clear some things up that you were kind of having trouble with, or maybe gives you some new ideas on how to set up equations. I always find it really beneficial when I hop on to other people's videos and see how they do things, because it helps me to better understand it myself and add to the knowledge that I already have. So thanks for watching. Hopefully that helped you guys, and good luck on finals. It's going to be a stressful week, but hopefully this video that I made helps you relieve some of that stress by making it slightly simpler for you to know how to do these equations. All right, we'll see you in class. Or actually, no, we won't. So good luck on finals. Hope everyone travels home safely, whatever you're doing, and have a good summer.